Hello, good afternoon. My name is Diego. I am one of the Conan co-founders, and today I'm talking about what is new in Conan 2.0. Spoiler, everything is new in Conan 2.0. Around 80% of the code base is completely new. Okay, and that includes 20% that we have backported to Conan 1 to make available a subset of the syntax, so we will allow an easy migration from recipes to Conan 1, from Conan 1 to Conan 2. Okay, we have basically been 5 years without breaking, and that major release includes all these major changes. Why are we changing that much? Because in these 5 years, we have had tons of feedback. Conan is widely used, it's very widely used. For example, in the CppCon Slack, the Conan channel is ranked in the most used channels in the whole Slack. This is from last month. This was the second most used channel by the number of different users using the channel. Conan gets around 600,000 downloads per month from the Python package index. We have also other releases like installers or something, not counted here. We have been designated as a critical project in the Python package index. That means we are in the 1% of the most downloaded packages in the whole index. And we also get tons of feedback from the users. Last year, we got more than 4,000 pull requests to the GitHub repos that we maintain. And of course, we get the pull requests, and we also get the issues. Last year, also, we responded around 2,000 GitHub issues. It's our main support channel. But we also did a bunch of video calls with users and customers. This is something that we do on a weekly basis very often. We also do tons of direct support with users, typically via Slack. And we also, because as we are part of JFrog, we also know how many people are using Conan because we have the telemetry for the Artifactory servers. That we know there are at least around 8,000 teams, companies, okay, last year that they were using Conan in production because they had their servers live and with Conan calls being used. The feedback was actually so large that we did a working group. And we gathered together around 70 people from different companies, like some of them there. And it is a feedback group. We have been iterating proposals for Conan 2.0, and we have been getting structured feedback from them. And yeah, I want to say thank you very much for this. We call it the tribe 2.0. Because without them, the Conan 2.0 would be impossible. So today, my talk, I've structured it in 5 lessons. 5 important lessons we have learned from the ecosystem during this time, and how Conan 2 is addressing these concerns. So let's start with the first one, learning to fly. Because we started with a relatively simple approach. We started step by step, slowly. The first thing we did was create recipes. We called the Conan file.py, we called them a recipe, and they contain the instructions, the methods, how to build a package from sources, like the source method, the build method, the package method. Okay? And then, of course, the next step after defining how something is built from sources is to define the dependencies, because we are building a dependency and package manager. Then we introduce the requires attribute to recipes. In this case, we have this game application, which is simulating a small video game. That to build the game application, we depend on an engine package, and we express that with a requires equal engine in the Conan file of the game package. And likewise, engine depends on the math library, on the math package, and it requires to the math package with a requires clause. So when the developer of the game needs to work on the game, the first thing they will do is a Conan install. They do a Conan install and they get the dependencies. Their dependencies, engine, and their transitive dependencies. And the second thing they get is the Conan generates for them files so their build system can locate those dependencies. In this case, it will generate 2 files for CMake. Okay? I'm using CMake in all these examples, but if you don't know, Conan integrates with any build system, including MS Build, Auto Tools, Meson. We have integration with all of them, native, and you can also use your own build system. But I'm using CMake for this talk because I think you all know CMake. So in this case, Conan will generate 2 CMake files that will help the game to locate those two dependencies and to link against them. But then we started to learn from the ecosystem. And yeah, we thought that a static linkage was good enough for most cases. No, it is not. There are tons of users out there. Approximately, I think half of the users in companies, they are using shared libraries in some place or others. And they were proposing us cases like this one. Hey, we have a game, but we have two releases. One of them is using Engine as a shared library, and the other one is using Engine as a static library. In both cases, we can assume that math is going to be a static library. Okay? But in both cases, Conan, you are giving me the math file, you are giving me the math target always. But I don't need to link with the math target always. Because when I'm using game with the Engine as a shared library, the math library is an implementation detail of the engine. I don't have direct visibility to it. So I don't want to link with the math library. So please don't generate for us this file. So basically for us at that stage was asking us learn to fly. We couldn't do that. We didn't know how to do that because we didn't have a model to represent that. We had a very naive requires equal something definition. So we decided to come up with something new. And this is the new proposal for Conan 2.0. As you can see, it's identical to the Conan 1. But the trick, of course, is that we enable something else. Optional argument that you can provide to the requires. In this case, we are expressing here that the engine package requires both the headers and the libraries from the math library, from the math package. Okay. This translates when the engine developers are working on the engine. That translates that the math config CMake file is generated, and it will have information both from the headers and for the libraries. But now the developer can start expressing what they want. Hey, I know for some reasons the engine doesn't use the headers at all. It has some, I don't know, implicit definition of the interfaces. So I know that the engine will not use the headers. So they can put the headers traits to false. And then that means that they will have a file that has removed the include directories properties in the config CMake files. And in a similar way, they can say, hey, I don't depend on the libraries. For some reason, I'm only using a header file from the math package. And please don't give me your libraries because I won't use them. I don't want to link with them. So they can put the libs trait to false, and that means that the generated file will remove the link libraries properties of the targets. The interesting part of this approach is that it can propagate. We can define some rules in which these traits propagate from the upstream consumers to the downstream consumers. In this case, when we have the game depends on engine and engine depends on math, that means that somehow game depends on math too. Indirectly, something. So we call that a transitive requirements is the orange box. It is similar as if game had requires to the math package. And the interesting part here is how these traits propagate from the upstream to the downstream. Let's say that we know that the engine is always a shared library. So the developer of the engine package can now explicitly say, I don't want to propagate the library requirements to the consumers. That means transitive libs equal false. That propagates to the downstream consumer to game, and then the traits that games get to the math package is headers false and library false. That means, hey, game doesn't actually depend on math when engine is a shared library. And as Conan knows those traits, it can define for the game developer, it can define a math config.cmake that is basically empty. Conan in practice can remove it. Okay? But the idea is that game will no longer get linkage requirements to math static library because you have a shared library in the middle. This seems a bit cumbersome because now it seems that the developers of the recipes, of the Conan recipes, should be specifying the traits all the time. And that can be a bit too much. The thing is that most of the times it's not necessary at all, because these traits can be deduced from the package types. We have that information in recipes, in some of them, because we have the options. The options, the standard one from being a shared library or a static library is called the shared option. Okay? So if we have this option, based on the value, we can deduce if we are a static or a shared library. And for those cases that we don't have this information, we have introduced, Conan 2.0 introduces, the new package type that can explicitly say if something is a static library, a shared library, a header-only library, or an application, for example. Let's see in practice. As I'm doing a talk about our tool, I always like doing live demos. I know it's a bit risky, so let's cross fingers. I've built here exactly the same example that I'm showing in the slides. I have the game package that depends on the engine, that depends on the math. Okay? So now I am a game developer. And I'm going to work on the game, on the executable, right? So the first thing I need to do is to install my dependencies. And I'm going to install my dependencies, and I'm going to work on the executable that uses the engine as a shared library. So I specify that as this. Engine 1.0 shared equal true. So Conan will install my dependencies for me. Now I have my project set up. I could open CMake, create my project, and start building. But what I wanted to show you are two things. First one, math. Here we can see in the dependencies, Conan is telling us math binary can be skipped. Why? Because it already has an engine package, and it's already in the cache. And as it is a shared library, and it's already compiled, you don't need the math binaries at all. So Conan knows that this binary can be skipped. It doesn't need to be downloaded from the server at all. And the second interesting part is if we check the files that Conan generated for us, we see that we will have some CMake files here, but we will not have math config files at all, because we don't need them. If we inspect the data that we have in the engine CMake files, we see that dependencies are none. It's an empty set. Because for the perspective of the game developer, math doesn't exist. It's already an implementation detail of the game shared library. But if now we try to do a Conan install with the default, which the default, by the way, is static libraries. Now, Conan will tell me, hey, you need the engine package in the cache, and you need the math package in the cache as well, because you are going to link with both static libraries. And if we check the generated files that Conan generated for us, we will see that it now represents the dependency, the transitive dependency between engine and math. It is here. And if we inspect the math files that now the math files have been generated because now I need to link with the math static library, we will see that we have the library defined here, we have the path to the library here, and also interestingly, we have that the include directories to the math package are empty. Why? Because if you want to use the headers of math in game, you need to put a requires, explicit requires from game to math. If you don't put that, that's a transitive headers. And by default, transitive headers should be hidden when we are talking about packages. That's software architecture at scale. Okay, so with this, we managed to have a much better representation of the graph and the requires in Conan 2.0, which correct linkage requirements with correct header visibility. We also allow the possibility, we know it's not great, but there are many users out there that have different versions of the same package hidden in shared libraries and using the same protocol at the same time. That is most expected, or more, you can find them more often than you would like. And many other things. I've been talking today about 3 traits. There are actually around 8 traits. So if you want to know more about the new traits, I would recommend that the talk that I did in ACCU in April, because it's dedicated only to this part of the talk. The cool thing about this is very similar to what CMake or other build systems are doing. We are propagating the linkage requirements and the headers requirements, but we are doing that among different build systems. We can have a dependency graph, and we can have 5 different build systems, and still the requirements will be correctly propagated. All the what we have seen works among different build systems. And of course, we need a compatible syntax, because we need to be able to move from Conan 1 to Conan 2. Second lesson learned. When we are talking about developers, we can assume that cats are a good default, right? Or maybe in our case, it is not. What I'm talking about the binary model, and a big mistake that we did. When we're talking about binaries, this is what we are doing. We have a recipe, and for every different configuration that we are building, we can create any number of binaries. Every binary is identified by a unique package ID. This package ID is a hash. It's the hash of the configuration, something like this. That means that if we change something in this configuration, we change library being static or shared, we get a different configuration and we get a different package ID because the binary is different. Or if we change the architecture, the same. Different configuration, different package ID because it's a different binary. This model, this is a simplified view. The full view is taking into account also the dependencies. Because if you are linking with dependencies, your dependencies also affect your binaries. In this case, having exactly the same compiler settings, architecture, options, and everything, if you change your dependencies and you use different versions of your dependencies, your final binaries are going to be different. How different? That's the question that we try to use with Semver. And we say, okay, we are talking about versions, right? Semver can be wrong. That's the default of the industry, right? So we decided to use Semver. And our interpretation of Semver means exactly this. We have these two dependency graphs. Okay, in one case, we are using math 1.0, and the other case, we are using math 1.3. Okay, that can happen because both satisfies the range in the engine. It's a range between 1 and 2, so both are perfectly valid requirements for engine. But for a package ID perspective, for a binary perspective, we understood the Semver specification as breaking the major is what a new binary means. So we say, okay, both things are Semver compatible because changing the minor is kind of Semver compatible, right? It doesn't break. So we assume it was the right approach. That means in both cases, the engine binary will be exactly the same. It should be exactly the same. Okay? And if we wanted to have two different binaries for the engine package, for the two different versions, we would need to do a major bump of the math package. Okay? In this case, if we have the math 1.0 and math 2.0, 2.1, they will actually create a new expression that we will feed into the configuration, and that will result in a different package ID. But if we had the minor only, the equivalent expression of 1.0 and 1.3 would be math 1.y.set in both cases, which result in the same configuration, which result in the same package ID. So the thing is, come on, when's a project, a C++ project, bump the major version? For example, Boost has never, in the last year, has bumped the major version. And the thing is that in the C++ ecosystem, we understand Semver a bit differently. So for us, the first version is kind of a generation thing, rarely changed, and when this change is completely destroying everything. And breaking changes are being done at the minor, typically. So Boost release is breaking. Every release is breaking. And that they only bump the minor version. But the most important thing here is the native compilation model. When we are linking a shared library with a static library, this is more or less what it happens. We have here the native code for Windows, and when we build the engine DLL shared library, it basically gets a copy of what is in the math static library. And it embeds the native code of the math static library. It embeds the code into the engine shared library. Of course, optimization can happen. I think this is a debug build, okay? But the main idea is that it is actually embedding, making a copy of it in the engine artifacts. This is something that doesn't happen in other package managers. So if we're talking about Python, Maven, the binary or the package model that they have is not native. So Semver works for them, but in our case, it's a bit different. And that means that we had to go with a new package ID model that handles two main use cases. The first use case is the non-embed, which happens, for example, when an application is using a shared library. Okay? In this case, the shared library is not embedded in the executable. Right? If a shared library uses another shared library, or if a static library uses another static library. In all of these cases, this embedding of the native code doesn't happen. For this case, we selected, for Conan 2.0, the minor mode, meaning that the developer, they have the control. Now, if you bump the minor version, that means that you get a different binary. But if you only bump the patch version, which is a patch and implementation detail, that means the binary ID, the package ID, will not change. That means you don't need to rebuild. We are going to see this in practice now. And on the other hand, if we are managing the embed case, which happens with an application is executable, is linking a static library, or when an application is linking a header library, or when a shared library is linking either a static library or a header library, in all of these cases, this embedding of the native code is happening. This inlining is happening. Okay. For those cases, that means that no matter what changed in your dependency, you need to rebuild. You need a new binary of the consumer. So what we did is we took the full reference of the dependency that includes the full version, the revision, which is an implicit version that we manage, and also the package ID itself. Because if the binary changes somehow, you still need to recompile. You need to rebuild the downstream consumer. And of course, all of this, you can configure that now. But the most important part is this dual model. Let's see it in practice. When we are developing this game, and sometimes the math team will release a new version. So let's see what happens. Conan create math, and they are going to release a patch version in this case. They did a minor bug in some of the CPP files and implementation details, so they fix the bug and they create a patch version 1.0.1. So the key question here is how this affects my binaries. Let me put it otherwise. What do I need to rebuild? Okay. So now I could be trying to build a game, but I'm going to show you a new Conan command, which is the Conan graph build order for the game. And tell me which binaries are missing. So Conan will analyze the dependency graph. It knows that the math, it now has a new version that fits in the range. And hey, this is an implementation detail. The engine static library doesn't need to be rebuilt. You can reuse the previous binary that you had, because we are assuming that you don't need to relink. If a change was done in the math CPP files, you don't need to rebuild the engine library. But in this case, we need to rebuild the game. The game executable should be rebuilt because it needs to relink with the changes that happen in the math library. Okay? And likewise, if now we ask for the build order, which binaries are missing for game, if I specify the engine as a shared library, now it will tell me, okay, the math, you have it here, it was created. You need to build the engine now. The engine shared library must be built because there was a change upstream that affects you. You got a new version, you need to do a rebuild. But once you rebuild the engine shared library, the game application doesn't need to be rebuilt. Okay, because it's linking a shared library, the shared library will embed the changes of the math, and it will not need a relink of the game executable. Again, as you can imagine, this is simple at this scale, but when we are talking, we learn that our users, they have dependency graphs about typical thing is 100, 200 packages, for example, so it starts to get big. And now we have users that are approaching the 1,000 package mark. So for them, it's very important to know when something changes in the middle of the graph, what needs to be rebuilt in an optimal way downstream that dependency graph. Of course, this can be like a bit weird there on the command line, but of course, this is intended for automation. If we check the JSON output of this command, we see that the JSON output of this command will retrieve me a list of things that need to be rebuilt. So I can take this input and I can parallelize all the things that need to be rebuilt at a scale, because Conan will tell me what needs to be rebuilt and in which order and how you can parallelize them. Okay, let's clean a little bit. Okay, so finally, it's not a cat, it's not a dog. The model that we need for binary representation in C and C++, native building, if you want to, is a bit more complicated. It's something like hybrid. And there is a hybrid that we need to differentiate between the embedded mode that we need to use. If you change anything in your dependency, you need to rebuild the downstream consumer of that dependencies. And in the case that it's not embed, we have full control. We have decided for a policy that allows developers to explicitly say if the consumers need to be rebuilt or not, depending on the changes. And of course, users can customize this behavior as well. And yeah, this will be a major enabler for scale. So these things were like related to the graph and how the binaries are computed. Another important lesson that we learned is that there are more people than developers. Okay, we had a very developer-centric view, and we were concerned about just the packages and getting my application running. But we also started to learn that many of these companies, they also have full DevOps teams that they need to get those things that you built and they are inside a Conan package, and they want to put them as Debian packages to distribute to servers, for example. Or they need to, I don't know, to create a zip for their users, for their customers, because they are not going to distribute Conan packages. And also, we learned that the ecosystem is extremely opinionated, as you probably know, more than other languages. And this is the typical conversation. We had users that they wanted to have their binaries not in the Conan cache. Conan, when you install something, it put it in a place which is structured, and it can manage it very well. But developers were asking, hey, I want those binaries in my project. And we were trying to, hey, there is no technical advantage to that. Actually, there are only disadvantages. And the conversation finished and say, okay, I want the binaries in my project. So as the problem is basically the same, is someone wants the binaries, the artifacts that are inside Conan packages, and they want them out. They want them in a user folder. They want to automate something with those artifacts outside Conan packages. So then for them, we developed in 2.0 the deployers concept. Deployers is an external script. It's a Python script that implements exactly this logic, how to extract things from Conan packages and do something with them. There are actually several different levels. You can have these deployers in somewhere in your folders. You can have them and you can install automatically to all your developers and CI machines with a single Conan config install command. Okay? And finally, we also have some built-in deployers. Let's have a look at this. Okay, I'm going to show you first the full deploy built-in, which is the one that implements this case of the opinionated C++ developer that they wanted the dependencies in their project. So if I'm developing the game, I'm a developer of the game, now I can specify that I want to use this deployer. Okay, apparently everything is the same, but if we check our project now, we will see that we have a copy of the binaries. We have for the engine, we will have the header of the engine, we will have the library here, and for math, we also have the headers and the libraries, and everything is inside a copy of my project. Furthermore, something that developers really wanted, if we check the CMake files that were generated, those CMake files are now pointing not to the Conan cache, but to the deployed copy in my current project. That means that I just achieved a folder here that contains absolutely everything. I could remove Conan from my system, and with just the CMake files that I have here in my folder, and the local copy of those artifacts, I could build my application with the dependencies. Also, let's go now with the case of the DevOps engineer that they need to create something. They want to create a bundle for their customers, for example. So all they need to do is to write their own deployer. A deployer looks like this. In this case, this deployer is basically iterating all the dependencies. For every dependency, is looking into the binary folder. If it finds in the binary folder a DLL or an executable, it will do a copy of that artifact into the current folder. Okay? And it will store that in a list. And when it has finalized copying all the X's and all the DLLs, it will zip them in a zip file and removing the copy file. That means that if the deployer, the DevOps, want to get the final product for their customers, all they want to do is Conan install. I want to deploy this version of the game, and I'm going to use I want specifically to deploy the one that is using engine as a shared library, and I'm going to deploy it with my custom deployer here. Okay, Conan does his thing, and we can check that now we have this runtime zip here, and inside the runtime zip, we will see that we have the game executable, and we have the DLL that can be shipped to the customer. Okay, so with the deployers, we learned that there are other people besides developers in companies, and they want to automate also some tasks. So we created these deployers as a flexible way to extract artifacts from the cache, to automate some post-Conan tasks, as well as creating Debian packages or other kind of installers. It's important because in Conan 1, this functionality was embedded in recipes, something equivalent. It was called the imports and the deploy methods in recipes. But that doesn't scale, because typically you want to have the deploy functionality and you want to apply it to many different packages out there. So we extracted the functionality of the deploy into its own dedicated file. And finally, you can manage these deployers with a single command. You can put them in a repo and then do Conan config install the repo, and it will install the deployers of your company or your team into your Conan installation, and you will be able to manage them. Okay, so then we learn the fourth lesson is the importance of repeating yourself. Why? Because we learned that companies, they need to reproduce the exact same build today and in 10 years. For example, the medical sector is absolutely insane. They also need to keep the hardware, copies of the hardware, so they can build exactly the same thing. And this also applies to dependencies, because dependencies change. They change, not only new versions of the dependencies, but sometimes also someone fixes one dependency without bumping the version, which we call it a revision. So sometimes things will change, okay? But still there is this need of repeat things. This is the problem that we want to solve here. Basically, the developer of the game at some point did a Conan install, got the engine 1 and the math 1.0, is developing, everything is happy, everything works, perfect. And then it happens that the math team, they decided to release a new 1.1 version. Okay. The day after, the game developer comes again to their machine, they do the Conan install, and because of the math package satisfies the range, now their dependencies will be different, and if there are a new bug in the math or there is something that changed behavior, they will be, hey, what is happening here? I didn't change anything. I didn't change my requirements because I still require engine 1.0, but still I'm seeing a different behavior. How can I get rid of this? And this is the problem that the log files solved. In this case, the game developer can say, hey, I installed my dependencies, but I capture a log file that will look something like this. Okay? A log file is basically something that captures the versions of the dependencies. Okay? So no matter if the math team decides to release a new version, the day after the game developer gets to the office, does a Conan install, they provide the log file as an input, and they will manage to get exactly the same dependency graph. Okay? This is the concept that exists in other package managers. You have them in NPM, for example. Okay? And Conan 1 implemented log files. Okay? The only thing is that they were so challenging. Why? Because the dependency graph, I think I will talk about this later. Let me show you a little bit about the importance of the log files. in the last 2.5 years, like 10% of the issues in GitHub are related to log files, or they mention log files somehow. Because at some point, when you are managing dependencies, you have to take a decision. You either explicitly pin all the revisions in your requires. That means that when a new version is released of some of your dependencies and you want to start using, you need to go to the projects, you need to modify them and explicitly change your requires to point to the new released version. Okay? This is, you have full control, but this can be also cumbersome and slow. So in those cases, there are people, there are developers that they want to go faster. And the way to go faster is to use version ranges, for example. That means, hey, I accept any version in this range. But when you start to use version ranges, you start to move faster. And if you move faster, things can break. Okay? You either need to be ready to move forward very aggressively. That means when something breaks, you go quickly and you fix it, moving forward all the time. Or if you need some kind of balance, you need to capture the log files to be able to reproduce something. Because otherwise, debugging or maintaining things is a nightmare. We estimate that around 25 to 40% of users are using log files nowadays. And the actual demand for log files is huge. We've seen it in other ecosystems like NPM. Finally, maintaining your log files is very necessary in many cases. So the thing that we learn also is, okay, this is the simple case of log files. Log files in Conan 1, they managed to implement this. The main problem is that you had to capture one log file per configuration. And that was a major challenge. Why? It happened that the dependency graph resolution in Conan 1 was not fully deterministic. So we need to capture the full dependency graph in the log file. And then as the dependency graph can change for different configurations, because there are conditional requirements out there, then you need one log file per different binary. Okay? But this was still doable in Conan 1. This, what I'm going to show here, was almost impossible. Okay. And it's the case that, hey, the math team released math 1.1. Okay. But we don't want it. We have logged it to math 1.0. We are not going to use that crazy release of the math team. They don't know what they're doing. It's plenty of bugs. But we need to release a new version of the game. There was something major in the engine. And now the engine team, which are my friends, they are releasing engine 1.1. And I want to test it. I want to release game again using the engine 1.1. But it should be using still the math 1.0 version, because I don't want to pull the new one. So I want this. How can I achieve this if the log file is telling me, hey, you are locking math and you are locking engine to version 1.0? But I want to change engine, but I don't want to change math. But how do you know? It's very complicated. So this is the problem that we learned from the ecosystem, that the enterprise DevOps at scale is a challenge. Why? Because I told you the typical dependency graphs are around 200 packages. But the thing is that they also have 200 developers. And their developers are doing pull requests to different packages at the same time. And the only way to keep sanity is that every dose of pull requests needs to be tested in isolation of the other changes, of the other new versions that the other teams are releasing. Because otherwise, you can build a pull request, and in the middle of the pull request, a new version comes up, and the first build for Linux is using math 1.0, and the second build in Windows is pulling math 1.1, if you are not actually locking to math 1.0 and testing in isolation. So this continuous integration at scale is something critical for the enterprise. Okay. I like to think in the same way that programming over time is software engineering. It happens that Conan is going beyond package management. We learned that, hey, finally the users were asking for this, so we developed this functionality for them. So we understand that package and dependency management over time, what happens when a dependency changes over time, that's more or less what the DevOps buzzword is about. Okay? And we are starting, Conan 2.0 is incorporating tools to serve the DevOps community that are handling, they are starting to use DevOps for C++ with Conan. So as I told you, the major contribution of the log files in Conan 2.0 is that they, instead of having the full dependency graph captured in a log file, they managed to put the log dependencies with their versions in just a simple list. And this is a game changer. This simplifies a lot of things, and this enables the power to do exactly what we want. Let's try to show it. Okay, let's go again to the game. I'm the game developer. The use case that I told you, I can do a Conan install, and I'm going to capture my log file. And I'm going to call it game.log. This is for demo purposes. If we name it Conan.log, it's going to be used automatically. Okay, but I'm going to put explicitly the commands there, so it's evident what we are doing. Okay, so this will be captured in the log files, and we can actually have a look, and we can see that this is this simple list. So this is something that the users can read and can understand. Okay, so if it happens that the crazy math team decided to release Conan create math, the 1.1 version, okay, and we don't want to use it, it will be relatively simple because now the game developer can say, hey, I want to use now as an input. In the previous command, it was the output. I was creating the log file. Now, as an input, I can provide the game.log, and that will guarantee that I'm still using math 1.0. Okay. Now, what I'm going to try to show you, I know it's a bit complicated, but let me tell you, this was a training that we had prepared in Conan 1. That was a 3 hours training for trying to solve what I'm trying to solve now in about 1 minute, which is the problem of what I told you. We now are going to be the engine team. So I'm moving to the I'm moving to the engine. Okay. Now I'm going to do a Conan create. I am doing some great improvements to the engine. Conan create with a new version, 1.1. And as, of course, we don't want to pull the crazy changes from math 1.1, I'm going to provide the game log file. Okay, the log file that I created, log file, and I'm going to create a new one, okay, because I'm doing a change. Okay, the previous log file contained engine 1.0 and math 1.0, but I'm doing a change, so I want a resulting log file. I'm going to do a log file out equal new.log. So the first thing, this will guarantee that we are using math 1.0. It will create the engine changes. And if we inspect the new log file, we will now interestingly see that we have two versions of engine, 1.1 and 1.0. No problem for this. Now we go back to the game developer, and we want to test the thing that the engine team did. So we do a Conan create, and we provide the log file that the engine team did. And this will guarantee, let it finish, this will guarantee that we will be using the engine 1.1, but we will still log to the math 1.0. And if we check the output of this execution of this, we will realize effectively we are pulling the changes from the engine 1.0, but the math package is still math 1.0. Sorry, is the time correct? Oh, so that is broken. Okay, thank you. Okay, so log files. Log files in 2.0 are is a game changer for continuous integration at scale. It enables in an easy way, in a way that developers can understand, because those lists of logged requirements are lists. You can merge them. You can merge log files from different products if you want to. You can add manually versions there if you want to, just to force the usage of a specific version in your dependency graph. Okay, the last lesson. You are an open source maintainer, and then you start to get a lot of feature requests. Feature requests like, hey, can you do please a Conan install, but after that, I want to, or Conan create, but could Conan remove automatically the temporary build folders? Please, can we add a configuration that will remove automatically the temporary build folders for me? Or I want Conan install to automatically install debug and release configurations in just one command. So please add the syntax to the command line so I can do that in one line instead of 2 Conan installs with different arguments. Or can we do a Conan create and then with a configuration or with a command line argument to do the upload to the server just after the Conan create? And then you realize that if you start doing those features, the complexity goes out of the sky, the command line is really cluttered. So it's certainly something that you cannot do. It's impossible because it will pollute your CLI in a great way. But what we learned from the community is that approximately 50% of the big teams using Conan, they are creating their own layers, mostly in Python, of automation on top of Conan. Okay, so it seems that they didn't want a tool. Of course, they want Conan. They wanted a framework to be able to develop on top of that framework. Okay, and of course, this is exactly what we did in Conan 2. We created a framework that is based on user custom commands. So basically, those Python scripts that you are already using, you can transfer them to Conan commands with a specific syntax. Those commands can be installed in your Conan clients for your developers and for your CI with just the same Conan config install command that we are using for profiles, setting, and deployers, and everything else. I'm going to show you this in code. The most important thing about the user commands is that now they will be able to build on top of a public and documented API. Because we had, in Conan 1, we had this API, which is basically a parallel of the commands. The command line commands, they map each one-to-one to an API. In Conan 2, we are creating a full-blown Python API. And you have details, for example, for the upload API, you have all the detailed steps that happen before an upload. How you are zipping the artifacts, how you are checking what needs to be uploaded because it exists on the server or not. You have full control over all those steps in the upload, in the installs, and everything. So you can build you can actually build on top of that instead of just the high-level command line interface. So this is how the commands look like. This is a very simple command, hello. We mark them with an annotation here. And you can have commands. You can have nested commands if you want to. We call them subcommands. It implements formatters. So if you want to have a structured format, different output formats of your commands, you can implement it as well. You have access to a nice colored output too. And of course, to the API that we will see. And the cool thing is that these commands, you can just install them with Conan config install. Here, you could use a URL, like a Git repo URL, for example, and it will fetch those things from the Git and put it in your Conan installation. In this case, for the demo, I'm using just the local folder. And this will be copying those commands that I have there in my folder and put them in Conan. That means that Conan help will show you these commands. I see that I have here this nice hello command. Of course, I could type Conan JFrog hello, and it will have a nice command line help. I could execute the command, which print me the hello world, or I could use the command plus the output format, which will be JSON. Okay, if we want to do something more useful, let's implement the case of users wanting to do this. They have a repo with a bunch of recipes, and it's Conan Center index-like style. Okay, and they want to export all the recipes one after the other. Okay, so they have asked for the Conan export command to do that automatically. Okay, and we didn't do that. But now with this, you can do this in just these very few lines. You take the command line argument to the path of the repo that you want to export. You check all the folders inside there. If you find a Conan file.py inside the folder, you call the Conan export API, and finally you capture the result of that API in the final result. And this is all you have to do. This implements the Conan JFrog multi-export to my current, sorry, I didn't show you. I have here a repo with a couple packages, AI and physics. So I can point here to the repo, and sorry. And it will go iterate all the repo, exporting each one, and I capture the result of this command. So if I want to see it, I can use the format equal JSON. It will do the export of every package there, and it will return me with a JSON list of all the recipe revisions that has been exported. I can use this output to automate further into my flow. Okay, so these custom commands, we are very excited about them too, because they are a very powerful extension that is convenient for both developers and CI. It will build on top of a Python API with real building blocks, and it's super convenient to be shared and installed and managed for your developers. It can even be versioned, because you can put in a Git repo in a certain branch, you can put in a numbered version zip file out there. Okay, so my conclusions. This was our Conan 1.0 release, a bit barbarian. Okay, and in these 5 years, we have learned a lot of things. And these are the major learnings that we did. The first one, the graph model was not enough to represent all the special things that we need in C++ building. We need to come up with a better graph representation, a better requirement traits and package types to represent how things should behave in a dependency graph for C and C++ packages. We also had to improve the binary model, because December was clearly not a good default. And we came up with a new model that takes into account when the embedding and inlining in native binaries happen and when they don't. We also handled the request from the DevOps people that they needed to take out the Conan artifacts out from Conan and deploy them in other ways, in other places with the deployers. We also solved the major pain of the log files and continuous integration at the scale. And we removed the complexity of the Conan 1 log files with a much better approach that allows now to test every change in isolation for a full dependency graph, a huge dependency graph, with tons of developers doing changes at the same time. And finally, we created a framework for maintaining your own automation, your own custom commands, and based on the Python API. This is not everything. This is like the 5 biggest lessons that we learned. Actually, as I told you, Conan 2.0 is quite big. So there are many other things that are in Conan 2.0 that I haven't talked about, like a cache that can handle multi-revisions. Package signing. We did a plugin, and we are collaborating with Sigstore to have package signing also. And other things, I'm very excited about the custom binary compatibility. We added a plugin mechanism that you can explicitly define the binary compatibility you want, for example, between compiler versions. If you know that, hey, my pure C packages, they have binary compatibility between minor GCC 4.1, 4.2, or whatever versions, you can encode that in a plugin that you own, that you maintain, that you install with Conan config install. Okay, and that will allow you to be way more efficient in the number of binaries, for example, that you create when you upgrade compilers. And many other optimizations that we did in Conan 2.0. So my conclusion, Conan 2.0 is going to be a game changer. Everything that I've been showing today is already released. This is the beta. We'll be doing 2 betas more, okay? And around 2, 3, depends on how it goes. And then we will go GA. So if you are using Conan 1 today, we recommend please start trying Conan beta and give feedback. And if you are not using Conan today, you are probably missing out. You should be starting, and please start with the 2.0 because it's the next thing changing. If you have any question, also go to the Conan.io. You have links there to our GitHub, to our email and everything, and don't hesitate to contact us for any question regarding the Conan 2.0. And thank you very much. And if you have any questions, please, you have the mic there.
Thank you. Is it possible to propagate compile flag from my project to all the dependency? Like if I want to enable sanitizer, is it possible that I set in my project and automatically get propagated to all dependencies?
You can propagation happening in 2 different directions. So you can have a package, for example, that defines we call it the CPP info. You can define the CXX flags there, and you can inject flags that will get propagated downstream. Those flags follow the same rules that we have seen in the threads. So if you put some CXX flags in some dependency, they will be injected to the consumers. Those CXX flags will, in the case of the shared library, they will be applied to build the end shared library, but they will not be propagating down to the consumer, to the final application, to the game. They will stop there. But typically, the case that you are talking about sanitizer is something that, in most cases, you need the whole dependency graph to be built with sanitizers enabled. So this is more like a setting. You want to model that as a setting, custom setting that you can inject in your settings.yaml and as a, I don't know, maybe a subsetting of the compiler. That will get automatically injected in all the recipes because everything should be built with the sanitizer's configuration enabled, right? So more than a CXX flag that you want to propagate, is more an input that the same way that you specify the compiler version, you want to specify compiler version, and I want to use these sanitizers or these sanitizer flags. So we added some in the profile. You can specify now in Conan.
So it cannot be an arbitrary flag. It needs to be like, you need to specify a setting.
No, we also added the new configuration is tools.build :CXX flags in your configuration section of your profile, and that will be injected in all the dependency graph.
And just quickly follow up, and all of this is going to be part of the hash of the package, like all the compile flag.
You have control over that. So by default, configuration items like these CXX flags, they are not put into the package ID, but you have another configuration that you can tell, hey, I want my CXX flags to be part of the package ID automatically. And that when I told you that you have full control over the package ID, is that you have configured. You can tell it, hey, I have this configuration that I'm changing. I want this to be part of the package ID.
Okay, thank you.
You're welcome.
Thank you for the talk. That looks like very exciting changes from Conan 1 to Conan 2. I have 2 questions actually. One was about what you mentioned with the traits for the requirements, like I want the headers or not, and that controls what goes into the CMake package config file. How does this handle conflicts if multiple of libraries in my dependency tree depend on something, and some of them want the headers and some don't, and stuff like that?
That's a brilliant question. If you have realized the traits are bool, are of type bool, right? Instead of going with CMake, public interface private, we decided to go with bool because there is another 4th case besides those 3. You need to also handle the case that you don't depend on anything, okay? Which CMake public interface cannot. So we made them booleans because at the end of the day, it's a mask. So when you have diamonds and you have configs in your dependency graph, not configs, but diamonds, in that case, if you have different traits, we have given the traits a semantics that they are additive. So basically, if you have a trait there that you need the headers of this, and you want these headers to be propagated no matter what the other branch says, because the final user will get the headers of that, because one branch said that they wanted the headers. That happens the same for the libraries. So all the traits are built with these semantics that they are additive, so we can handle the dependency graph propagation in that sense.
Okay, thank you, good. And my other question comes from my prior experience working with Conan. It may be one of the 1,000 bytes, if so, then I'll shut up. But I couldn't actually think of a way to do this as sort of built on top of Conan, or I could, but it was an ugly hack. When running Conan create, sometimes I found myself needing some sort of build time configuration for the package, like here is a path to something or something like that. If it's done as an option, it will propagate into the package ID and etc. So is there a way to pass some, let's say, creation time arguments into Conan create?
Well, the mechanism for providing custom user input now is the new configuration. So the configuration is both for built-in configurations that we have, but there are also user.whatever user configuration that you can manage, and you can read those configurations in your recipes to do whatever you want.
Okay, yeah, that's it.
And basically you have full control. We have gone from trying to be a smarter Conan 1 to the developer, the user controls everything, and they have full control with the toggles and everything. In this case, the configuration, we have enabled user-side configuration.
Sounds good. Thank you very much.
Thank you.
Excellent talk. I'm looking forward to a lot of these things.
Thank you.
So back to the header propagation and library propagation concept. When you specify, let's say, headers equals false in your requires, is that saying that the package that we're building right now will use the headers, but we won't propagate them?
No, the headers equal false in our requires mean that the current package doesn't use the headers of the dependency. I can give you an example. Let's say that the mythical protobuf package that contains the headers, the libraries, and it also contains the proto-C compiler. Okay? So when you are depending on protobuf on the build context, you put headers equal false, libs equal false, and run the runtime equal true, because you only want to access the runtime in build context for that. So that means, hey, I don't want the headers of this package. That's what it means. The transitive headers and the transitive libs traits are those who defines how those things are propagated to the downstream consumers.
Okay. Oh, so there's a transitive headers one. Okay.
Yeah, there's a transitive headers. Yeah, it was in one of the slides. There's a transitive headers trait, and there's a transitive libs trait.
Okay. That sounds like exactly what I want. Thank you.
Thank you. Any other question?
Yeah, maybe one more. So creating the new log file. I remember there's some recipes where the requirements of the package are dependent on options or platform and so on. So how do you capture the full, set?
Yeah, exactly. That's a very good question with log files. So I've said that now you only need one log file to capture all the possible configurations. If you have variations and you have conditional requirements, what you need to do is you need to do the Conan install for as many configurations as you want to log, passing the log file both as input as an output. And it will keep adding the new things that are conditional in some platforms and not conditional. And the cool thing is that even if it is a list, it works for all configurations. So it works. Yeah. So you only need to call the different configurations one after the other, providing the log file both as input and as an output. And time is over. Thank you very much, everyone.